Now that we've learned how to multiply like bases, let's learn how to divide like bases. Um, Division is basically the opposite of multiplication, so when I go and show you why this works, it should be equally clear as to where the rule comes from. It's kind of the inverse of what we talked about before. Remember, for bases to be the like, they have to be the same. And remember, the base is just whatever is below the exponent. The base can be a number or a variable. In this case, it's a variable, but the exponent, for the sake of what we're doing now, is going to be a number. Okay, so let's go ahead and start with numbers. Okay, we have 2 to the 7th divided by 2 cubed. Notice the bases are the same, they're both 2. What I want to do again, like we did when we showed, multiplying like bases, is I want to break these down even further. 2 to the 7th is 2 multiplied by itself 7 times. 2 cubed is 2 multiplied by itself 3 times. So I'm rewriting the fraction by breaking these down into separate 2's. But notice what happens. There's going to be 3 sets of 2 that will cancel with each other because 2 divided by 2 is 1. And that happens 3 times, but 1 times 1 times 1 is still 1. So basically it just goes away and we're left with 4 2's. Now if you take 2 and multiply by itself 4 times, that's the same as 2 to the 4th. Yes, I know it's 16, but what we're trying to get at is, look, we started with 7 on top and 3 on the bottom. In effect, what happened is 3 of the 2's on the top and bottom cancel, and so we ended up subtracting those. We took away those 3 2's on the bottom. What are we getting at? When you divide like bases, you take the top exponent and subtract the bottom, because those 2's or whatever those bases are going to be are just going to cancel. So if we had just done 7 minus 3, we have seen that the final answer is 2 to the 4th. Okay? This is getting at the rule that when dividing like bases, you just subtract the exponents. Again, when multiplying like bases, you add the exponents, but when you divide them, you subtract them. Let's look at a variable since, we need to kind of generalize this thing. Let's say we had x to the 6 over x squared. So we'd actually have 6 x's on top multiplied by themselves and 2 on the bottom. And again, we can see that those 2 x's on the bottom are going to cancel with the 2 on the top. We're going to be left with 4 x's. And we know that 4x is x times x times x times x is just x to the 4th. So again, we can see that if we just subtract the 6 minus 2, subtract the exponents, we get the final answer of x to the 4th. Again, when dividing like bases, subtract the exponents. Let's go ahead and get into some more examples. If we had x to the 15th over x squared, we can quickly apply that rule. 15 minus 2, since we're dividing, is 13. That's it. Again, we want to make sure, though, if our final answer is negative, we want to make it positive and put it under 1. Again, I'm going to talk about in a future lesson why that is. But for this one, we don't need to do that because it's positive. So the final answer is just x to the 13th. Again, x to the 15th divided by x squared is x to the 13th. Next example, we have y to the 6th over y to the 7th. Now I'm going to show you 2 different ways to do this problem. First way is the way that we just learned, and the second way is a shortcut, and you can decide which way you like better. The rule we said was we're going to take the top exponent, subtract the bottom, okay? Well, 6 minus 7 gives you negative 1, right? Not positive 1, and so that's where the steps 2 and 3 come into play. Since it's a negative 1, we're going to make it positive and put it under 1. We're going to take that negative exponent, move it to the denominator, and again, once we move it to the denominator, we make it positive. So final answer, well, actually, this isn't the final answer, right? Because this leads us to step 3. What is 1 over y to the first? Well, anything to the first power is itself. So the final answer is 1 over y. So that is the long way, okay? We subtracted the exponents. We got negative 1. We made that positive and put it under 1, and then we realized anything to the first is itself, so the answer is 1 over y. The short way, which to be honest with you is the way that I prefer, we're going to rewrite the problem y to the 6th over y to the 7th. Okay, and so what I want you to think about is which of these exponents is bigger, 6 or 7? All right, the answer is the 7, right? The shortcut is just to start with the bigger exponent and subtract the smaller. Your answer is going to go wherever the bigger exponent is. So for this particular example, 7 is bigger than 6, okay, and 7 minus 6 is 1. My answer is going to go on the same side as the bigger exponent 7, so I'm going to put my y to the first here, and since there's nothing left on top, we have to put a 1 there. That's the shortcut, okay? And I'm actually going to show us a few more examples on the same page so you can see how easy this is. And then, of course, we would want to simplify that to 1 over y, because anything to the first is itself. But let's do a few more on this page, just so for those of you who like this shortcut, you can use it in the future. Let's say we have, actually I'm going to use a new page. Actually, we'll just stay on the same page, and let's do another example like that. I want you to be comfortable with this shortcut. Let's say that we had something like x to the 7th over x to the 10th. Now, the way shortcut works is which one has the bigger exponent, okay? Again, the bottom has the bigger exponent, and so what we can do is we can do 10 minus 7 and just put our answer wherever the bigger exponent is. 10 minus 7 is 3, and since 10 was bigger than 7, okay, we put the answer on the bottom. I'm going to do one more just to solidify the concept. This time I'm just going to use a number because sometimes students don't necessarily, they think that somehow variables and numbers are different with this rule. It's the same. You always just divide. All right, but this time I'm going to make it a little bit trickier, okay? I'm going to put negative 3 on top, 4 to the negative 3. I'm going to put negative, let's do negative 1 on bottom. Okay, now this one's a little tricky, but let's just take a look at this. Okay, which of these exponents is bigger? Okay, when you first look at it, it looks like negative 3. But in fact, we know from the number line that negative 1 is bigger than negative 3. I'd rather be $1 in debt than I would be $3 in debt. So that's one way of looking at it. All right, we're going to apply the same rule. We're going to take the bigger exponent and subtract the smaller. Okay, again, this one is a little bit trickier. What is, and I'm going to show my math up here, what is negative 1 minus negative 3? Well, it just becomes negative 1 plus 3, which is 2. Okay, and so I'm going to have to erase this so we can actually show. But we see that negative 1 minus negative 3 is 2. And so guess what? We're going to put a 2 down here. Okay, as crazy as that looks, that is actually completely legitimate. And in some ways, it kind of, you know, if you were to do it the long way, it would even take even more work. But just take the bigger number, subtract the smaller, and put your answer where the bigger number is. Since negative 1 is bigger than negative 3, you put the 2 there. And of course, if we wanted to simplify this all the way down, it'd be 1 over 16. Okay, so that's dividing like bases, and that's the shortcut. Let's take a look at another example. This one also has 2 negative numbers involved. We're going to do it the long way this time. Of course, we'll do it the short way as well. We have z to the negative 4 over z to the negative 8. We've shown that you just subtract the exponents. We can just take the top and subtract the bottom. In this case, actually, never mind. The shortcut wouldn't apply because negative 4 is already going to be bigger than negative 8. So take the top exponent, negative 4, subtract the bottom. Negative minus negative is positive 8. Negative 4 plus 8 is positive 4. So the final answer is z to the 4th. Z to negative 4 over z to negative 8 is z to the 4th. I really can't stress this enough. When you're doing these problems, okay, if you're taking a quiz or test, whatever, you need to do exactly what I just did here and show your work, because I can tell you so many times students skip this step and they might put z to the negative 4 or z to the negative 12 or something that looks like the right answer. All you have to do is take the top exponent and subtract the bottom. It's not that much extra work. You're going to save yourself a lot of points, a lot of credit, a lot of grade, whatever you want to call it. You're going to save yourself a lot of missed problems. You can get a lot of problems right just by showing this subtraction step when dividing like bases. So that's it. That's both the short and long way of dividing like bases, and I showed you the reason why we apply that rule. And guess what? If you have any other questions about this lesson, just let me know.